circumference of a circle is 20 pi. Find the radius and the area of the circle. To find the radius of the circle, remember that the formula for the circumference of a circle is 2 pi r, where r represents the radius of the circle. And since we're given that the circumference of our circle is 20 pi, we can set up the equation 20 pi equals 2 pi r. Now, to solve for r, we divide both sides of the equation by 2 pi. On the right side, the 2's cancel, and the pi's cancel, and we're left with r. And on the left side, the pi's cancel, and 20 divided by 2 is 10. So we have 10 equals r. So the radius of the circle is 10. Now to find the area of the circle, remember that the formula for the area of a circle is pi r squared. And since the radius of our circle is 10, we have pi times 10 squared, or 100 pi. So the area of the circle is 100 pi.
Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d.
In this example, we're asked to use the circle shown to find the value of x. Notice that we have two secant segments drawn to a circle from an external point. And remember that if two secant segments are drawn to a circle from an external point, then the product of the lengths of one full secant segment and its external segment is equal to the product of the lengths of the other full secant segment and its external segment. And notice that the length of the full secant segment at the bottom of the figure is 3 plus 13, or 16. So we have one full secant segment times its external segment, or x times 6, is equal to the other full secant segment times its external segment, or 16 times 3. Solving from here, we have 6x equals 48, and dividing both sides by 6, we find that x equals 8. this example, we're asked to use the circle shown to find the value of x. Notice that our given angle is formed by a secant and a tangent. And remember from the previous example that the measure of an angle formed by a secant and a tangent is equal to half the difference of the measures of the intercepted arcs. And in the diagram shown, since the measures of the intercepted arcs are x degrees and 70 degrees, we can set up the equation 30 equals 1/2 times x minus 70. Remember that when finding the difference of the arcs, we always take the measure of the arc on the far part of the circle minus the measure of the arc on the near part of the circle, relative to the given angle. Now, solving for x in our equation, our first step is to get rid of the 1/2 by multiplying both sides of the equation by 2. On the left side, 2 times 30 is 60, and on the right side, the 1/2 and 2 cancel out, and we're left with x minus 70. Next, we add 70 to both sides, and we find that 130 equals x.
I kill the wishful thinking in my peaceful...
In this example, we're asked to use the circle shown to find the values of x and y. Notice that x represents the measure of an inscribed angle, so we know that it equals half the measure of the intercepted arc, which is the arc shown here. Since we're given that the two parts of this arc measure 95 and 37 degrees, then the full arc measures 95 plus 37, or 132 degrees. So x, which represents the measure of the inscribed angle, equals 1/2 times 132. 1/2 times 132 is 66, so x equals 66. Which means that we can replace the x in our diagram with 66. Next, to find the value of y, remember that if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. This means that the angles that measure 66 degrees and y degrees are supplementary. So we can set up the equation 66 plus y equals 180. Solving from here, we subtract 66 from both sides, and we find that y equals 114. In this example, we're asked to use the circle shown to find the value of x. Notice that x represents the measure of an angle formed by two chords. And remember that the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intercepted arcs. And in the diagram shown, since the measures of the intercepted arcs are 60 and 110 degrees, we can set up the equation x equals 1/2 times 60 plus 110. Solving from here, we first simplify inside the parentheses. 60 plus 110 is 170, so we have x equals 1/2 times 170, or x equals 85.